Hi guys, today is Wednesday. I will be out today and the next 2 days. So what we're going to do today is we're going to continue on situational graphs, which is what we were working on yesterday at the end of class. Okay? I'm not going to re-go over this stuff when I get back, so it's really important that you pay attention here. And I can answer questions when I get back. But we're going to go ahead and look at graphs, and we're going to look at the story the graph is trying to tell us. When we're doing that, we want to make sure we're paying attention to the x and the y. What does the x represent? What does the y represent? And as a reminder, this is the x-axis down here. The one like this is the x, okay? And you'll see on this one, it's talking about time, and this one is talking, this is the y, and it's talking about speed in miles per hour, okay? So what this reads, it says, a car traveling at 0 miles an hour accelerates to 25 miles an hour over the first 5 seconds. It maintains that speed for the next 5 seconds and then accelerates to 48 miles an hour during the next 5 seconds. So what we're looking to do is look at which of these graphs, A, B, C, or D, best represents this situation. Okay, so a car traveling, so the car starts at 0 and accelerates. Accelerates means goes up, goes faster, to 25 miles an hour. So we're gonna wanna start at 0, okay, and we're gonna wanna go up 25 miles an hour. So that means we're gonna have a positive slope. Immediately I look at A and I'm like, ooh, that's a match. Okay, so let's see if it continues that way. Over the first 5 seconds. So did it take 5 seconds to go those 25 miles an hour? So I go over 5 seconds, and at 5 seconds I'm at 25 miles an hour. So far that's a match. Okay, I go here, and this is going down, so I'm like, definitely not it, because I'm accelerating. I'm starting at 0 and going to 25. All right, so let's go back to this one and see if it continues to work. It maintains that speed for the next 5 seconds. So maintains means it's just going to stay at that same rate. Does that look like it's staying at that same rate? Yeah, there was no change there. Okay, and then accelerates. Accelerate means goes up or goes faster. Okay, to 48 miles an hour. So this is going up. Does it go up to 48? Yes, it does. So this is my choice. Now this one was kind of obvious. They're not all going to be so obvious. Because if you look down here and here, neither one of these started at 0. A car traveling at 0. That tells us that we're starting at 0. Okay? All right, let's keep moving on. It says select a graph for this situation. You wait for the express bus for 30 minutes. So we're waiting for the express bus for 30 minutes. Okay? Get on. So you get on the bus, you wait. So as you're waiting, are you going anywhere? Because you're going to pay attention to the fact that this is distance and this is time. So we're going to distance and time. So you wait for 30 minutes. Which one of these shows me waiting for 30 minutes? 30 minutes, I'm going somewhere. 30 minutes, this could be wait. 30 minutes, no. So I'm waiting for 30 minutes. If I'm waiting, I'm going no distance. If I'm waiting, I'm not going any distance. So then you get on the bus. So as you're on a bus, so you're traveling, you're going somewhere. Okay, so it's waited for 30 minutes. Down here, it shows I'm not going anywhere. I didn't get further away from where I was. I just stayed here for 30 whole minutes. I stayed. Okay, and then you ride a bus nonstop for 3 miles. So it just shows to 0 miles to 3 miles. Okay, and then walk another mile. So then you walk another mile. Well, this is the obvious choice here because when you ride the bus, notice the rate of change is much quicker here than when you walk. So choice D. It says, which graph most likely describes the number of steps taken by a person in 24 hours? Now, when somebody's walking, can you lose your steps? Oh, a lot. You can lose money, but you can't lose steps. Okay? So think about this. Which graph most likely describes the number of steps? So what's going to happen as time goes on, time is always your x, what is going to happen here? Okay? Are your steps going to go down? Are your steps going to go back and forth? Or down? Or your steps going to go up? Okay, notice it's this one. This is the only one that keeps going up. Your steps can't come back down. Your steps can go only up. All right, which story goes with truth graphs? Now this time we're going to match the story with the graph. Now this one can be a little bit trickier. Okay? All right, it says, I had just left home when I realized I'd forgotten my books, so I went back home to pick them up. Notice this is time, the X is time, and the Y is distance from home. Okay, I just left home, so he left home, and I forgot, okay, I'm struggling with that one, so I'm gonna come back. I left home, things are going fine, so I'm driving away. I got a flat tire. Left home, I'm driving. So notice my distance from home, I'm getting further from home. When I get my flat tire, I stayed exactly where I was. I was moving nowhere when I got my flat tire. Then I got the tire fixed and headed to the library, and so I headed back to where I was going. So this graph goes with B. Okay, I started out calmly, but sped up when I realized I was going to be late to my friends. So started off at a slow rate of speed and then sped up because I was going to be late. I'm going to go with C. All right, so let's decide. I just left home, so I left home, when I forgotten my books, forgot about my books. Okay, so I went back home. Which one of these shows going back home? Did I head back home? Because notice, this is home. This is home. So I just left home when I realized I'd forgotten my books. So what did I do? I went back home. So I went back home to pick them up, and then I was at home for a little bit, and I went ahead and went to the library. So this would be A. You really got to pay attention to what the X and Y variables represent. Okay, this one here is talking about a canoeist. A canoeist starts from a dock and paddles to the end of a lake and back. This graph shows the canoeist's distance from the dock during this trip. Okay, so a canoeist starts from a dock and paddles to the end of a lake. So he starts at his dock and he goes all the way to the other end of the lake. And then he comes back. Okay? This graph shows the canoeist's distance from the dock during this trip. How long did his trip take? So the first question is asking me, how long did my trip take? Well, let's go ahead. This is the start of his trip right here, and this is the end of the trip. Let's look at how long did that take from 0 to 4. That's how long? 4 hours. How far is it to the end of the lake? Okay, notice he went to the lake and then he came back. So how far from here to here? How far is that? You're going to pay attention to your y-axis. It is 6 kilometers. Okay, what does the flat portion of the graph represent? What it's talking about is right here. Okay, we know if a line's flat, that means there's no change. Okay, so let's look at the story. It says the canoe starts from a dock and paddles to the end of the lake and back. So when he got here, this was the end of the lake. What did he do here? Well, we don't know exactly what he did. We could guess. Maybe he stopped to have lunch. Maybe he took a break. Maybe he went to rest. Maybe he took a nap. Basically, that means he didn't go anywhere. He stayed put. Okay, stopped to take a break. All right, let's go ahead. This is the graph shows Tom's journey from his house to his friend's house. So notice this is distance from home. So this is Tom at home over here. Okay, this is Tom at home. Okay, and he's going to his friend's house. This is important because with some of the questions it's going to ask, you have to understand what it means. Okay, describe what might have happened in section B. What happened in section B? Did he continue to his friend's house or did he went back towards home again? Why would he have gone back towards home? Well, we don't know. But what might have happened in section B, he thought he forgot his phone and he headed back home and then he realized it was in his bag and not his pocket like he thought it was. Maybe he saw a friend down the street and headed away from his house to go talk to his friends. Okay? And so he turned back closer to home is the point there. Because notice, again, this is distance from home in meters. So he got 100 meters away from his house and he turned back towards his house for some reason. Okay? Again, there can be multiple answers in that situation. During which portion of Tom's journey was he moving at the greatest rate? So basically, when did he have the greatest rate of change? Well, let's look at A. We started here and we got here. We rose how many? 100. And we ran 50. So this is 100 over 50, which equals 2. So his rate of change here was 2. 2 kilometers a second. 2 kilometers per second. Okay, let's take a look here. He rose 20, 40, 60. He rose 60 here, from here to here. He rose 60 and he ran 10, 20. So what's his rate of change here? 60 over 20 is 3 kilometers per second. Now let's look at C. From here to here. So I rose 20, 40, 60, 80, 100, 120, and then 10, 20, 30. 120 over 30 is 4. So choice C, okay, journey part C was 4 kilometers per second. So in portion C, he went the fastest. You can also take a look at that. Sometimes it can be tough. You can say, which part of my line is the steepest? Which one has the greatest rate of change? And that would be portion C. Notice we didn't even really talk about D because is there any rate of change? No, definitely not moving the fastest there. Okay, what might have happened in section D? Well, we could say he got to his friend's house and he stopped to talk. He got to the park and just realized he wanted, a little bit of quiet time. He got to his friend's door and rang the doorbell. We don't know. Okay, so what we're going to look at more today is telling stories from graphs. Okay, situational graphs is what this is called, or story graphs. Okay, so go ahead and get started on your work. Try to make sense of things. Make sure you're understanding what your axes tell you. Okay, it's not all about speed. Notice again, this last one was distance from home. This has nothing to do with his speed per se. Okay, in time, in seconds. So this doesn't mean he's going downhill. Pay attention. Again, just because the rate of change is negative does not mean something's going downhill. In this situation, it meant he turned back and went to his house. So go ahead and get your work from the sub. Make sure you're on task, and tomorrow we're moving on to a new topic. Remember, I expect you to have amazing behavior and be the awesome human beings that I know that you are. Have a great day, guys.